All right, now let's look at our solubility rules. Solubility rules are kind of like a logic puzzle. Okay, when you predict your products, then you go through your solubility rules to see, all right, well, what's going to stay aqueous and what is going to crash out as a solid precipitate. So we've got all these different rules, like common compounds of group 1A and ammonium ion are soluble, common nitrates, acetates, perchlorates are soluble, common chlorides, bromides, and iodides are soluble, except, okay, so then there's going to be some exceptions here. Okay, so here we have an except. Those of silver, lead 2, copper 1, and mercury 1. Common sulfates are soluble except those of calcium, strontium, barium, and lead 2. Okay, then insoluble compounds. Okay, common metal hydroxides are insoluble except those of group 1A and larger members of group 2A that begin with calcium. So that would mean that beryllium and magnesium hydroxides would also be insoluble. Carbonates and phosphates are insoluble except those of group 1A and ammonium. Sulfides are insoluble except those of group 1A, group 2A, and ammonium. Okay? Here's another way of putting the whole thing together. We've got our soluble, our insoluble, and then C exceptions. Or here's the way your textbook presents it with, again, soluble and insoluble, and then exceptions off to the side. Now, solubility rules are something that you do need to memorize. Okay, we do expect you to know these off the top of your head. These are important. This is not just something I want you to memorize for, funsies for the sake of memorization. When you're in the lab and you're doing an experiment, it's really important to be able to understand what's actually occurring in your experiment. And solubility rules help you know what's going on in your experiment. A few semesters back, I had a student over the summer that did not take 120 at Grossmont and was taking 141 with me for a summer class. Their school did not make them memorize the solubility rules. This particular student spent, I would say, an hour to an hour and a half getting increasingly frustrated with their work, thinking that something was going wrong. I kept checking by with the student throughout the lab. Are you okay? Do you need any help? It seems like you're struggling with something, and they kept telling me, I'm fine, I'm fine, I'm fine. Finally, they came to me and said, I don't know what's going wrong. Every time I do something, I'm getting this solid precipitate crashing out. I said, okay, well, what are you reacting? And they told me the reactants. I said, well, what about the solubility rules? What do your solubility rules tell you? Oh, well, I don't know anything about solubility. Well, if they had known their solubility rules, they would have known that the hydroxide compound they were forming was indeed insoluble, was supposed to crash out, and nothing was going wrong with their experiment. So they wasted an hour to an hour and a half freaking out because they didn't know their solubility rules. So solubility is important. It's a very practical thing to know. So we do ask that you memorize your solubility rules.